Hello everybody, this is Mr. Baker here again just to give you a quick tutorial from some of the homework that we have for tonight. I'm going to work out 3 problems for you today, number 3, number 12, and then on the back, number 22 down here. So, each of these is solved using a different way because for the first set of problems we are solving for the measure of the indicated angle, specifically theta. So to solve for theta, we need to first identify all the aspects of this triangle, sides, so we can figure out what trigonometric ratio to use and go from there. Now, if theta here is my selected angle, my given angle, I can identify that using an arrow, draw that this BC is my opposite side, opposite the right angle, 9 is the measure of my hypotenuse, and 6 here, my leftover, must be my adjacent side. So, I'm going to color code this a little bit. We are given, in orange here, my adjacent side being 6, and we are also given 9, my hypotenuse, in red here. So to set up the appropriate trig ratio, I need to find which one of my trigonometric ratios uses the adjacent leg and the hypotenuse. Well, that must be the cosine. The cosine of my angle, theta, is going to be equal to the measure of my adjacent side, which is 6, over the measure of my hypotenuse, 9. From here, I take the inverse operation. I use the inverse operation to cancel out that cosine. I take my inverse cosine, the cosine -1 of the cosine of theta is equal to the cosine -1 of 6 over 9. Now, when I have the inverse cosine and the regular cosine, those cancel, and I would get that theta is equal to the inverse cosine of 6 over 9. Now, on your calculator, here is my example calculator, I'm going to hit second cosine of 6 divided by 9. And that will give me some decimal answer. The measure of theta then is going to be 48.189, or we can just say 1.48.2 since it says round to the nearest tenth. Theta is 48.2 degrees. Remember to use your units. Also, other reminder. Since we are dealing with degrees, you need to make sure if you are using your calculator that it is in degree mode. So you can go to mode and ensure that it is in degrees. For those of you guys who do not have a graphing calculator at home, there's a pretty neat website that you can go to. I'm going to throw this up here real quick. You guys can pause on here if you need to write that down. That is www.calculators/calculators/trigonometry/inverse trigonometric functions.php. For x, you need to make sure that you type in the decimal to get the correct answer. And also remember that arcsine is the same thing as the inverse sine. Arccosine is the inverse cosine, and arctan is the inverse tangent. So, when you're plugging in that calculator, make sure they will use arcsine, arccosine, arctan. Remember, that's the same thing as doing each of these. Do not plug in 6 over 9. Use the decimal answer, 6 over 9, if you're going to plug that in your calculator. That is 0.66 repeating. Okay? Hope that helps for you guys who do not have graphing calculators at home. Now, going back to my next example, let's move on to number 12. It says, find the measure of each side indicated. Sorry, I folded it in half so we can fit it on this iPad picture. Find the measure of each side indicated, round to the nearest tenth. This is what we did yesterday. So, they give us this angle, 60 degrees. Let's label my sides based off of that selected or given angle. This would be my opposite here. Here is my hypotenuse, opposite the right angle, and my given side here, or not my given side, what we don't know, x, is the adjacent. So again, we are actually dealing with the adjacent side, what we don't know, x, and we are given the hypotenuse, which is 11, which means that we must use cosine. Specifically, the cosine of 60 degrees is going to be equal to x, my unknown, the adjacent, over the hypotenuse, which is 11. From here, we need to get x by itself, so let's multiply both sides by 11. Those 11s cancel, and I'm left with x is equal to 11 times the cosine of 60 degrees. Remember, this is just a number, so if you guys want to work that out first, you can, or for those guys using the online calculator, you can work out what the cosine of 60 degrees is from there. So, the cosine of 60 degrees is actually something pretty straightforward. It's 1/2. Cosine of 60 degrees is one of those really cool, unique values that you'll learn a lot more about later on in a calculus class or a pre-calculus class when you talk about something called the unit circle. So you would multiply 11 times 1/2 is equal to x, so x is 11 halves, or for those of you guys that are more decimal fans, that's equal to 5.5. There is no units here because this is a side, so we're good in that department. On to the very last example problem. We have number 22 here. We are given a series of angles. Here we have 24 degrees, we have this right angle, and we have this unknown angle B. Now, without having to use any trigonometry, we can figure out what angle B is by subtracting these two from 180. We know all the angles in a triangle add up to 180. This is a 90-degree angle because it's a right angle. That is 24 degrees. So 24 plus 90 plus x, my unknown, or we can use theta, since I know you guys are trying to use the new terminology, right? The new symbols, is going to be equal to 180. 24 plus 90 is 114. So 114 plus theta is equal to 180. And my final answer after subtracting 114 from both sides, theta is equal to 180 minus 114, which is 66 degrees. Okay? Degrees. Now, to solve for the other sides, we need to set up my trigonometric ratios. Let's go ahead and start with my newfound value b to help me solve for some of these. We know that we can set up two specific ones to solve for my opposite here and my adjacent side here. We'll call these y and x respectively. X is going to be the opposite, y is going to be the adjacent. So if I were to take the sine of theta, that would be the opposite over the hypotenuse. The sine of theta, which is 66, remember theta is 66, is going to be my opposite x over the hypotenuse, 14. So to solve for my opposite side, multiply both sides by 14, and I get 14 sine of 66 is equal to x, that opposite side. 14 sine of 66 would give me the answer of 12.8, remember we're using nearest tenth, miles. Now there's two options you can use here. You can go ahead and use the Pythagorean theorem, or we can use another trigonometric ratio. Since you guys have had a lot of practice with trigonometric ratios already, I'm going to, with Pythagorean theorem, I'm going to use a trigonometric ratio. Let's use cosine to solve for y. So the cosine of 66 degrees is going to be equal to y over 14. So to solve for y, you're going to multiply both sides by 14, and 14 times the cosine of 66 degrees is equal to y. If I plug that in my calculator, that gives me an answer of 5.7 miles. If you use Pythagorean now to check, you'll find that that checks out, and you can see that this side here is 5.7 miles, my adjacent side, and my opposite side is 12.8 miles. So I try to color code it so you can see which goes where. Hope that helps you guys out. Good luck with the rest of the sheet, and we'll see you tomorrow.